Okay, today in class we talked about triangle congruence, and we learned that in order to prove the definition of congruent triangles is that they have three sets of congruent angles, corresponding congruent angles. Corresponding, remember, means matching in the same spot, and three sets of corresponding, so in the same spot, congruent sides. So we had to prove all 6 things basically to prove that these triangles are congruent. Well, in 4.4 we start talking about shortcuts, and these shortcuts are called SSS and SAS. So we're going to use SSS and SAS to basically shortcut, bypass proving 6 things, but still prove that these triangles are also congruent. First thing we need to know is triangle rigidity. Basically, because triangle sides are rigid and not flexible, if a triangle has 3 side lengths, which they all do, then it can only make that one triangle. So basically what I'm saying is, if I told you, for instance, that this angle, this side was 4, and this side was 6, and this side length was 7, no matter which way I turned this triangle or how hard I tried to bend these sides, it will only make this shape. It will only make this triangle, regardless of if I rotate it around. So because of that fact, we have SSS. And that says that if we have 2 triangles and they have the exact same sets of sides, so if you notice here, this 4 is like this 4, this 6 is congruent to this 6, and this 7 is congruent to this 7, then those triangles are going to be congruent to each other. So if I was going to write that down in my own words or pictures, I would show that if I know that all 3 sides are congruent to each other, all 3 corresponding sides are congruent to each other, then that means that they're going to be congruent. Pretty cool. And the second way, the second shortcut is called SAS. And SAS, pretty much, instead of it being side, 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 we're talking about one side, one angle, and one other side. And actually, I forgot, sorry. We have to go up. In order to do SAS, we need one more vocab, and that's called included angle. The included angle is the angle in between 2 adjacent sides. And adjacent, remember, means next to or touching. So for example, angle B is the included angle of AB and BC. It is touching, it is in between AB and BC. And that included angle helps us out with SAS. So SAS says, now if you notice in these triangles, we only have 2 sets of congruent sides, right? We have that AB is congruent to EF, and we have AC is congruent to DE. And we don't know what this third side is, and we don't know how to figure it out yet. We don't have the tools yet in geometry to figure that out. This isn't a right triangle. If I know that this included angle, notice these angles are congruent to each other and they're both touching those 2 sides. They're the included angle. If those 2 angles are congruent, then it doesn't matter how I try to change this triangle, they will always be the same. So if I was going to write that down in my own words or have my own picture, I would say, okay, I have 2 sets of congruent sides this time, and that angle in between those 2 sides are congruent. Then I know that those triangles are going to be congruent to each other, and that's SAS. And how I remember that angle is in between is the SAS actually tells me that angle needs to be touching both of those congruent sides. This angle touches that side and this side. This angle touches both congruent sides. So that's how I know that that's the included angle. And those triangles will be congruent. I don't have to go ahead and tell you all the rest of the information. I don't have to prove that. I know it's a fact. And I can show you why tomorrow in class. We're going to skip the proofs. We'll do the proofs another day. Promise. Let's go ahead and skip down to example 2.5. 2.5 says state what additional information is required to know that the triangles are congruent for the given reason. So what that means is these triangles are not yet necessarily congruent. I need one more piece of information. If I wanted to use SSS to prove that these 2 triangles are congruent, what else would I have to say? Okay, well, SSS, I know I need 3 sets of congruent sides. So what do I have so far? So far I have XZ is congruent to ZY. I have, oh, I'm sorry, ZV, my bad. And I have YZ is congruent to ZW. Okay, so what's that third side that's missing? These are the third side. So I would have to say the missing information is that XY needs to be congruent to YV. So now it says write a congruency statement. So a congruency statement, remember, is triangle whatever is congruent to triangle whatever, and it tells us all the sides and all the angles that are congruent to each other. So I look at the tick marks, and I am boring. I just go 1 tick mark to 2 tick marks to 3 tick marks, and that lets me know I'm doing it correctly. So for example, XZY, 1 tick mark to 2 tick mark to 3 tick marks is going to be congruent to, I'm going to do it in the same order, 1 tick mark to 2 tick marks to 3 tick marks. So that's, I'm sorry, that's VZW. And I can check my work by looking at the statements. So XZ are the first two. That should be congruent to VZ. Let's check. XZ is this one and VZ is this one. That's true. Those are congruent to each other. So I should be correct. Nice. Number 7 says SAS. So this time I want to prove that these two triangles are congruent to each other, but not by SSS, by SAS. So let's think. SAS, I know I need to have 2 congruent sides and a congruent set of angles. So what do we have so far? I know that QR is congruent to QS. That's 1 set of sides. Sweet. I don't see that other set of sides yet. But if you notice, QP is in both triangles. It touches both triangles, and it's got to be congruent to itself. So that's going to be my second set of sides. Now that angle, I know that angle needs to be in between those 2 sides, touching it. This angle touches both sides, and this angle touches both sides. So now I just need to write that down. And that would be angle. It wouldn't make sense to say angle Q. I'm going to write it over here a little bit bigger. So that angle is RQP is one way to write it. It would be congruent to SQP. SQP. And now I'd have to write my triangle congruency statement. So I want you to go ahead and fill in those blanks, just like we did over here. Which 2 triangles are congruent? Okay, I'm going to do number 8 and 10, and then you guys are going to do 9 and 11, and then we're done. Number 8 says, which postulate, if any, can be used to prove that the triangles are congruent? Again, the only 2 postulates we've learned, the only 2 shortcuts are SSS or SAS. But I want you to look for hidden information. The hidden things that you need to look for are vertical angles, and let's see, the reflexive POC. The reflexive POC was when, like here, was when this side equaled itself. So when triangles share a side, that's when you're going to have a congruent side. So let's see. For number 8, I see some vertical angles here. But let's see. I don't know anything about this third side, so it can't be SSS. Is it SAS? That angle has to be touching both of those congruent sides. Here's one, but this other one should be here. It should be touching both of those sides, and it's not. So there is nothing that we can use to prove that these triangles are congruent. So you're going to try number 9. Same kind of process. Is it SSS or SAS? Last thing we're going to do. Example 3 says verifying triangle congruence. Verify means prove it right. So show that the triangles are congruent for the given value of the variable. So I'm telling you that these triangles are already congruent. You don't have to tell me SSS or SAS. But is it true that they're congruent if x equals 5? So let's see. Notice that they gave us 3 different side lengths, no angles. So I know I'm going to be using SSS to prove that these triangles are congruent. Now I have to look for corresponding sides. Which ones are the same? So for example, which one looks like NO? Well, NO should be congruent to QR. So that's what it tells me right here in the congruency statement. So I know NO is 5, and I know QR is X. So X would equal 5. Boom, that's true. I've do that for every single side. So I've done this one and I've done this one. Now I'm going to look at number 7. 7 is NM. That should be like PQ. PQ is X plus 2. If I solve this one, do I get X equals 5? Yes, I do. Sweet. Last one, I know these two should be congruent to each other. So 3x minus 9 equals 6. If I solve this, do I get X equals 5? Yes. I do. And that's all you have to do for number 10 and 11. So 11 is the same thing. Go ahead and finish number 11. That's all you're responsible for. Fun fact of the video, the world's most stolen food is cheese.